Now is it audible? Is it audible? Hello, hello. Can you hear me now? I think now it will be audible because I see here it is there. Yeah. Okay. So maybe some issue at that end on the microphone or something. But now it is. Okay. Now am I audible? Hello. Let me just check. Yeah. Sure. So here I think am I audible now? Am I audible now? Huh, yeah. So I'll explain that again. So see what this is all basic theory. I'll write here that this is basic theory. Okay, basic theory is there, and this is one of the most important formula that is required to be remembered. Euler-Lagrange equation is given by here. Okay. All right. Now, am I audible or not? Hello. Okay. Yeah, I can hear now. So let us go ahead and see the next formula. Now see, the formula has different versions. Okay, the first formula has a different version. I'll write over here with another color. Different versions of one. Now what are the case? You see the cases and then you apply it. So if your function, if f of x comma y, okay, if f of the function f of x comma y dash is now of the form f of x comma y dash, okay, then then this is the first case, so I'll write here case A. Then Euler Lagrange formula changes to it is just daba y by daba y daba f by daba y dash equal to c. This is the formula that you will have. Okay. Now the next one. So this is the new formula when this is there. Okay. Alright. Another version of formula is like this. Now this is slightly different version. Second form of the Euler equation. Here you write here second form of Euler-Lagrange equation. What is that format? Now this is written here in this way. What do you do here is dabba f by dabba x. That is there in the first formula also. But now something extra is here. Minus d by dx. Okay. F minus y dash into dabba f by dabba y dash is equals to 0. This is the formula. Alright. So you write down this formula carefully, and then we see another version in this also. There is another version here when, so here I'll write the C version when f is of the form f of y comma y dash. Okay, that is f does not contain x explicitly then Euler-Lagrange equation is of the form Yeah, now am I audible? Hello. Yeah. Okay. So here the Euler-Lagrange equation which we have, it's of this form now. The format is slightly different. It is f minus y dash into dabba f by dabba y dash equals to c. This is the format. Okay. Yeah, hide that. That is there. I will wait. So the next one. Now, if f does not contain, we have just seen here one formula that when f does not have y, when f does not contain x, we saw f does not contain x, we saw, and now we are going to see the format when f does not contain x. We have seen y dash also. If f does not contain y dash, what happens? Let us see. F does not contain. Now f is equals to of the form f of x comma y. If this is what happens, then then dabba f by dabba y is equals to 0. This is one thing. And the last format we have is this one. The third format of the Euler-Lagrange equation. Just then over here we will have another equation here is third form of Euler-Lagrange equation. Now this is slightly different and slightly rather it's more detailed version. It's rather the same thing but in a more elaborate format. This is here in this way. Dabba f by dabba y minus dabba square f by dabba x dabba y dash minus y dash into dabba square f dabba dabba y dash minus y double dash into dabba square f by dabba y dash square equals to 0. This is how it is. Okay. Now all these are different formats that you have and this is very straightforward. Also, I am not entering into the detailed proofs of here. The proofs of each of them do not uh, come in the examination exclusively. Okay, we will see how to find the questions and these are the main formulas that are expected to be remembered by the student in the examination. So this is the second format. Here this is the third format. The out of the second there is one formula that you have. Okay, this is what you have and then the last one here. These are the important formulas that you will have. Okay, if you have written down these formulas, please hit like or yes, just reply in the comment section so that I will go ahead. Once you are done with the formulas, let me know in the comment section. Okay, yeah. So people are there and some of them have joined and they have written down the formula. So here now we will go for solving the problems and what kind of problems are asked in examination. Here in most of the examination this topic is related to bit of physics as well as related to bit of engineering questions. It is not an exclusively mathematical topic. To each of the question which is there, there is a physical interpretation that can be given, but you can take the mathematics out of it and you can exclusively solve for mathematical kind of questions also, but then you have to give it physical meaning later on. But then these questions largely appear in the physics and engineering kind of questions. So let me take up the question and what is to be done. I'll help you out with this. Okay, so here let us take up the first question. Question in exam will be asked in this manner. Generally, this is what is the thing they ask. Find the extremal extremals of integral x1 to x2 y dash the whole square divided by x square dx. So how are we supposed to handle this kind of question? So what we do here, first we see this. Here the answer we write is this way. Here f of x comma y dash is, see, the function which is given in the bracket in the integration sign is what we are concerned with. Now here we can see it is x square, here it is y dash the whole square divided by x square. Now you can also see that, note here that function f of x comma y dash does not have y terms. Okay, y terms are not there, does not have y terms. Therefore, I can now write here, this can be now written as f of x comma y dash. Therefore, y dash square divided by x square, right? You can start like this also, but now when it is not there, when the term does not contain y, we are supposed to use the format which we had written up. The format is going to be the equation of, yeah, here we are going to use, therefore Euler-Lagrange equation will to be used is dabba f by dabba y dash equal to c. This is the format of the equation we are going to use. Okay, so what now you do, see, listen here, y dash meaning derivative of y. Okay, but now note here one more thing is there. Now note, in this topic in this topic y dash is to be treated as a variable, as a variable. Don't don't give it a meaning of derivative initially. We will give it afterwards. Y dash means derivative, okay, but we will give it that meaning afterwards. So now when I take the derivative, when I take the partial derivative of the function, so what is this? I am now going to do, I have f of x comma y dash as y dash square divided by x square. Okay, so do the derivative with respect to, therefore dabba f by dabba y dash will give me dabba by dabba y dash y dash the whole square divided by x square. Okay, now 1 upon x square is treated as a constant. Okay, so 1 upon x square comes outside, you get 2 y dash as your answer. That's it. Now what will happen? This is what you got. Therefore, we now write this is equal to c, right? So dabba f by dabba y dash is equal to c, implies that 2y dash over x square is equals to c. Correct? We have got this thing now. Now we simplify this a bit more. Therefore, what happens here? Y dash is equals to x square into c divided by 2. Now you give the meaning of y dash as derivative. Okay, this is the time you are expected to give the meaning of derivative to the term over here, so you will get some answer. So let's say here you have dy by dx. When you give the meaning x square, so at this step y dash is equals to dy by dx. Okay, so this is derivative, right? So you can now take the integration on both the sides. It is a differential equation basically. This differential equation, when you solve, you will get your answer. So this is basically a variable separable differential equation. So therefore this is dy, so you can write c upon 2x square dx, right? And then you integrate it here, dy c upon 2x square, you integrate this also with dx. What do you get? You will get y and then c upon 2 into x cube upon 3 plus some another constant, let's say c1. So your final answer is y upon cx cube upon 6, sorry, y equals to cx cube upon 6 plus c1. This is your answer. So this answer that you wanted to find is going to be your extremal. So is the required answer. Okay. So this is what is there in your part to be done. Now let us take up another kind of question in which we get to see a different variety of function and everything else. So let us see how to handle this kind of question. We'll write this question here. Find the extremal for extremal of integral x1 up to x2, right? And this is very popular kind of question which is asked in many examinations also. So you can mark this important question too. You can mark this important. It's very many times I have seen this kind of question coming in various examinations. So here again, and now I write the thing directly, that f is of the form f of x comma y dash, right? So the function is here, it is 1 plus x square into y dash into y dash. Like this it is written and given to us. So we are now going to simplify this function first. Let us simplify this. So on simplification, what do you get here? Y dash plus x square into y dash the whole square, right? This is what you will get. Hello, are you able to follow this? Following? Yeah, please let me know in the comment section. Are you following this or not? Hello, please let me know in the comment section, because this topic has a very new thing, that y dash is to be treated as a variable. So now Euler-Lagrange equation that we will use. Let me know in the comment section whether you are following or not. Yeah, yeah, fine. So therefore Euler-Lagrange equation to be used is dabba f by dabba y dash equal to c. Now we will do over here in this way, see, because I can find this exclusively. So I'll write here dabba by dabba y dash. What is f? It is y dash plus x square into y dash the whole square. Okay, this whole thing is equal to c, that we are saying. Now when you take the partial derivative of y dash with respect to y dash, it's going to be 1. Okay, this is 1. When you take the derivative over here, dabba y dash into x square into y dash the whole square equal to 6. So when I do this derivative, what happens is here is that 1 remains 1, and here this x square comes out as a constant. The derivative of y dash square is going to be 2y dash equal to c. So now again I am here in a position where it is a differential equation. This is a differential equation, remember that. So I can now solve this differential equation as to my liking. So let us see how to solve this differential equation. 1, here this one I will transfer it on the RHS, so it becomes x square into 2y dash is equals to c minus 1. Okay, and now c minus 1 is a constant, basically it will be some constant. So I'll right now here write, let c minus 1 equal to, let's say, some a constant c1. Okay, I'll put it as c1. So therefore I'll have here x square into 2y dash is equals to c1. Now what happens to this question? Let us see. Here 2 into y dash is equals to c1 upon x square. Followed this much? So what happens to this part next? Let us see. Here the next part will become y dash. I can now write y dash as a derivative. Okay, 2y upon yx. 2 dy by dx is equals to c1 over x square. This is what you will write, y dash as a derivative. When you write, you get this. So dy here alone, and you can transfer this c1 over 2x square into dx can be written like this. This is variable separable, right, which is variable separable differential equation. And now you can integrate it. Integrate dy. If you want, I'll write here. This is variable separable form of the differential equation. Okay. So what happens over here is dy, and then there is c1 over 2 integration dx over x square. Now you integrate it over here. When you integrate on the LHS, you get y. Here you will get c1 by 2, and on this, when you integrate it, it is x raised to minus 1 over minus 1 plus some constant. Let's say c2 is some constant over here. So my final answer over here is going to be minus of c1 upon 2 into 1 upon x plus c2. Alright, so I get this as the answer. This is my final answer for the entire question. Now you will say that this is the answer. If you leave your answer here, it is not wrong. Okay, yeah, hello, 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 thanks for joining. Please do write down your notes also over here, and ask other people also to join. It is very important topic, and you can also, you know, uh, uh, put it in the comment section for others. Yeah. So see what is very important over here. This is the answer that you got. No problem. This is the final answer. But now because it is all constant game, okay, the constants can be adjusted, etc., and all that. So what can be done in this case? You can still do little bit adjustment. So you can say let minus of c1 upon minus of c1 upon 2 equal to capital K. If I say it as capital K, then my answer becomes therefore y is equals to capital K upon 2, because it's a constant. So I'm just replacing the constant by another constant. So capital K upon x plus C2. This is the final answer. This answer is also right. The above answer is also right. Both the answers are correct. Generally, when all these MCQ exams and all are done, they will try to give you this kind of answer. Okay. In your final exam, you write this or this, both are right. Okay. Both are correct answers, but generally they will prefer the last answer, which I gave you, this one. Okay. This is the required answer. Required answer. Alright. So now let us take up another question which has a different kind of understanding and a little harder way of solving. Let me help you out with another kind of question, because see, all questions don't go in the same manner. Depending upon the kind of function is there in them, you can get your different answers. So try to do this question for your practice. You can try this, which we right now did was here was oh yeah, you can try this on your own. This is also easy. Try this as your part on practice. You can do this here as find extremal of x1 to x2 x plus y dash into y dash dx. This is the question, and here this is your answer for this is going to be y equal to minus of x square upon 4 c1, sorry, minus of x square upon 4 plus c1x plus c2. This is the answer. You can adjust some of the coefficients, not a big problem, but then try to handle it carefully. Okay, this is one question that you will have in exam, or if you can try, then this is your practice question. Okay. So I'll do the next kind, a slightly difficult looking version. Let me help you out with this one. Here the question is, find extremal. Again, every time all the questions will be there in your exam in this format. There are more different types also, but right now for beginning purpose, let me take up some easy versions so that gradually our difficulty level will increase. So you become confident with the topic. So the extremal, find the extremals of x1 to x2 square root of 1 plus y dash the whole square divided by x square divided by x. Initially we'll take x, then later on we will see. Okay. So here in this case, how to handle this kind of question, let us see. Again, here we see that there is no y, so therefore your function f is of the format square root of 1 plus y dash the whole square divided by the whole thing divided by x, and this is f of x comma y dash. Therefore we have dabba f by dabba y dash is equals to c. Now we will do the derivative here. So taking the derivative dabba by dabba y dash square root of 1 plus y dash the whole square over c, over x is equals to c. You do this. Now when you take the derivative here, 1 upon x will come outside because it is constant. While doing the derivative of this function, you have to be a little bit careful. Be very careful because the first thing is that when you do the derivative of, it's a composite function, so chain rule will be applied, and do it very carefully. 1 upon x is taken constant. So now we will do the derivative. Therefore 1 upon x into this one will be 1 by 2, right? It is power half is there, and then it will be, here it will be 1 plus y dash the whole square raised to minus half times 2 times the derivative of y dash, and y dash is to be treated as a variable. So 2 times the y dash you will get. Okay, so this is what you have here, and the 2 and 2 will get cancelled. So have you followed this derivative? Have you followed this derivative? Please let me know in the comment section. Have you followed this? Because this is again, y dash is to be treated as a variable. Please remember here. Okay. Yes. Okay. Fine. So this is very important. Others, what about others? Have you followed? Yes. Okay. Fine. So now this 2 and 2 gets cancelled. This 2 gets cancelled. So what is remaining is 1 upon x into y dash in the numerator. That power minus half is there, so it will go in the denominator and it will become 1 plus y dash ka square ka power half. Okay, this whole thing, it will be like this. This is what you will be left with. Now again, when I try to simplify this, this is going to be little bit different and slightly different. So let me help you out how to handle this again. So see this, we have to try to now solve this, how to handle it now. So y dash over here and cx and this thing here 1 plus y dash square and this is power half. So what I will do, I don't want that power half. So I will square on both the sides. So what do I get? Y dash square. Denominator, the half will go away and I will have y dash square equals to c square x square. Getting that? Okay, now is this variable separable? Yet it is not variable separable. It can, you can treat this as variable separable, but I want y dash alone. Till the time I don't get y dash alone, I cannot handle because it is derivative. So far I was treating y dash as the variable, that was fine. Ho gap. Variable work is over. Now what is the job we are trying to do? This is a differential equation. The moment you see this thing happening, it is a differential equation, remember. So how to handle this differential equation? That is what we have to see. So here now there are more difficult questions also. So some differential equations you may not have learned, so you need not worry about them. But the one which are easy, these are easy ones. But in easy, slight difficult. So I'm helping you out with these. So what you do is y dash square here c square x square into 1 plus y dash square. You take it on the other side. You take that whole thing on the, from the denominator you take it on the other side. What happens now? C square x square, multiply this one inside here and multiply it inside here. Inside here meaning along to this term. So what will happen? Plus y dash square, yeah, yeah, fine, y dash square into c square x square. This is what you will have. So y dash square. Now you take y dash, this term, this full term, you take it on the other side here. Take this on the other side. So what do you get? Let us see. Here you will have y dash square minus y dash square into c square x square, which is equals to c square x square. Now I will be able to take that algebraic manipulation which is there. It is 1 minus c square x square, which is c square x square. Therefore, y dash square is equals to c square x square divided by 1 minus c square x square. Now I am in a position to write the differential equation in the first order, right? First order, first degree I can write. See here, I can write y dash can be now made c x, take square root on both the sides, so this will become square root 1 minus c square x square. Getting that? Alright. So this is one thing that you will be able to get now. This is what is very important and very straightforward according to me. Alright. So we have got the thing here and we are now able to get the whole thing here. So this here, when you get, take the square root, after this put dy by dx. Okay, cx over square root of 1 minus c square x square. This is variable separable again. Okay, if you want to note down, you can note down here. This is variable separable form. Okay, got this? This is variable separable form. समझ में आ गया? Hello. I hope you are following this. समझ में आया? ओके, तो अब वेरिएबल सेपरेबल आ गया है तो क्या करेंगे? इंटीग्रेट कर दीजिए. यू कैन इंटीग्रेट योर डायरेक्टली ऑल्सो इफ यू इंटीग्रेट लाइक दिस, और better you do a variable separable way because you are mentioning. Yeah, बराबर, बढ़िया है. So 1 minus c square x square, this is what you have, and now you integrate here, integrate dy. Here you integrate c over square root of 1 minus c square x square dx. Can you see that it is directly the derivative? Right? So if we say on the RHS, here there will be some constant C1. So here you will have y equal to c times integral x over square root of 1 minus c square x square dx. So how do you integrate this? C1, I'll put 1 minus c square x square equal to, let's say, put m. The moment you put m, what will happen here to the derivative? Therefore, dm by dx, when you calculate, it is going to be minus of 2c square x. Correct? So, therefore, dm upon minus of 2c square is equals to x dx. Right? So, therefore, you have y equals to c times integration dm into root of m, and there is 1 upon minus 2c square plus c1. Okay, and so here you will have c upon minus 2c square into m raised to half, so m to the power m raised to minus half, sorry, so here it will be m raised to half over half. The integration that you will get is c1, here is y. So what all things you get is minus of c, right? C and c gets cancelled, half and 2, that is also getting cancelled, and then you will just have here is square root. Resubstitute m, that is 1 minus c square x square plus c1 is your answer. This is your final answer here. I hope you understood this. Is it easy? Followed this one. This is very important according to me. So please remember that whenever such kind of things are given, you have to carefully solve. Yeah. Okay. Let us go for the next one. And now this one is slightly different and a very new kind of thing for all of you. So this will be helpful to you. There are questions which are there which can be asked, but now I want to take the major type of question. So I'm going for one. I'll do one example on the basic type. This is extremely basic one. I'll do one basic so that you know uh, get refreshed with all the formulas, because they can come anytime and anyhow they will ask. So the next question is this. Let's take up the next question. Find the extremal of integral x1 to x2 1 plus y square divided by y dash square dx. Now see, here it's a very different kind of function given to us. Here we first always see your function. Here f is of the form 1 plus y square over y dash the whole square. All of you, I would like you to check that which formula of the Euler-Lagrange equation will be applicable, because my function over here is only in the terms of y and y dash. So y and y dash is there. X terms are not there. Which formula will be applicable? I'll show you the formula that we have gone through so far. Yeah, the formula that will be applicable is this one. See this. When this is the formula that we have gone through. Do you recollect it? Please recollect, this is the formula that we will need to apply. Very, very important. Getting that? If you remember this, please note down this. Now the formula we are changing. So Euler-Lagrange equation is now absolutely different, which we are going to use. Okay. So now write down. Now Euler-Lagrange equation to be used are, or to be used is, rather, to be used is f minus y dash times dabba f by dabba y dash is equals to c. This is the format that we are going to use. Now what is f? F we have already written. So you label this one and calculate individual components first and then write, otherwise you will make mistake in this, because all the components are differently settled and they are very different in the nature. So dabba, consider, write down, consider dabba f by dabba y dash. What is that going to be? That is going to be 1 plus dabba by y dash over 1 plus y square over y dash square. Okay. So over here 1 plus y is constant. 1 plus y square is constant. The derivative will operate only on 1 upon y dash square. Okay. Note. Please note down here. Note that one plus y square is treated constant with respect to y dash. Okay. With respect to y dash, this is treated constant. Now, what do you go about here? Dabba f by dabba y dash is equals to 1 plus y square. Now, dabba, how much this is the derivative? This is going to be When you take this in the numerator, it is minus 2, right? So here it is y dash raised to minus 3 into minus 2 is the thing that you will get. The derivative of this. So it is basically derivative of something x raised to minus 2 derivative. It's going to be minus 2 into x raised to minus 3. So this is the answer. So here also that similar format is here. That is what I have written. So therefore your dabba f by dabba y dash is 1 plus y square divided by y dash cube into the whole thing multiplied by minus 2. Have you followed this? Please give a thumbs up if you have understood this. Any smiley, any emoji you can write down, I don't mind. But let me know you have understood this. समझ में आया है? Please tell others also to join in. It is a very important thing. Yeah, okay, fine. Okay, now here कोई आया नहीं है तो जिन लोग को आया है उनको बेनिफिट मिलेगा पर ज्यादा आएंगे तो अच्छा है ना मोर द मेरियर so now when you do this part let us see how to handle this further here you have to be very careful while solving again see there is now we have to substitute in the formula so what is the formula we have f minus the formula had this thing, right? Formula had f minus y dash into dabba f by dabba y dash equal to c. So the moment I substitute f, what do I get? 1 plus y square divided by y dash square minus y dash multiplied by 1 plus y square multiplied by minus 2 divided by y dash cube equal to c. Generally cutting of the function doesn't happen but over here you can because you are treating them as variables. So here it will become plus 2 1 plus y square divided by y dash square equals to c. Okay. Now what do you get? Denominator is same so I can write this as 3 1 plus y square divided by y dash square equals to c, right? This is what it can be done. Now let's go further. When I go further I have another thing coming here. I want now this is a differential equation, remember that. जब तक इक्वेशन को सॉल्व नहीं किए थे तब तक मजा था अब ये जैसे ही सॉल्विंग में आ गया है it will become a differential equation, remember that. So 3 1 plus y square c into y dash square. Okay, this is what you have. And let me see something more that I can do here. So I can write this here in this manner: 3 upon c 1 plus y square is y dash square, right? Now I'll now say let 3 upon c be some number. Let 3 upon c equal to c1 कर देते हैं, no problem. This constants can be adjusted, not an issue. Therefore c1 into 1 plus y square is equals to y dash square. So this is basically here c1. You can do your adjustment also, not a big problem. Okay, इसको c1 कर दो या c1 स्क्वायर कर दो, कुछ फर्क नहीं पड़ेगा. सो c1 यहाँ पर लिया है, तो अब you have 1 plus y square is equals to y dash in का root हो. Take the square root on the other side. Now what you do is you get root c1. Okay, and this is square root of 1 plus y square equals to y dash. This root c1 can be written as something, you can write some number over there, not a problem. So put root c1 equal to capital K, no problem. Therefore capital K into root of 1 plus y square equals to y dash. Now what is y dash? Y dash is dy by dx, right? Therefore capital K into 1 plus y square is dy by dx. This is a differential equation. So how do you do? This is variable separable. So capital K into dx in dy by square root of 1 plus y square, right? So you have this over here. Now this is variable separable. You can write here, which is variable separable. Having said that this is variable separable, what do you get here? K, you can integrate now on both the sides, dy over square root of 1 plus y square, and this here will become k into x. Now what is this? Integration of 1 upon square root of 1 plus x y square. This is nothing but sin h, hyperbolic sin h inverse of y. Okay, there is that log and all that is there. I won't enter into that right now, but this is here in this way. So and I'll have one constant attached here. Okay, c1 or c2 I can call it, c2 for some time. Some constant will attach here. So this c2. So this is here you have, therefore sin h k x plus c2 is equals to y. This is what is the answer for this question. Okay, here what you need to remember, formula that you need is note that integration of 1 upon square root of 1 plus x square dx is sin h inverse of x. This is one formula that you must know. Okay, these are the kind of question you can practice these two questions for yourself, and you will be able to get some answers. I'll give you their answers also. Take down this question for your practice. Integrate x1 to x2 integral x1 to x2 y dash square minus y square dx. Okay, find the extremals of the above. Okay, find the extremals or solve. They generally say find the extremal or extremize. This is also the word they say, extremize. Okay, they will just say extremize. Okay, so okay, so this is the kind of question you can get, and how to handle. This is what is there. Okay, and the answer for this you will get. I'll give you the answer. The answer here is going to be y equal to c sin x plus k, something like that. C sin x plus k you can do, and you will get your answer for this kind of question. You can try one more on the similar lines. Again, there is similar things only there are there. Only thing is that the things are going to change a bit while solving. The another question you can take is again extremize x1 to x2. The thing is y2 minus y dash the whole y square minus y dash the whole square dx. You have to extremize. Okay. Thing is question extremize it. Answer is y is equals to again same answer c times sin x plus some constant k. The same answer you will get. So this is about the basics. Okay, I have done part 1 of this today. The remaining part, the difficult part of the whole thing, I'll do in the next lecture. Okay, till then, thank you for joining in. Please practice these questions. Let me know if you have any difficulty. आपको पसंद आया है तो please hit like and share it with your friends. Tell them to join in and watch this. Please let me know your comments in the comment section. Those of you who have understood it, comment कर दीजिए. जो आपको समझ में आ गया है, then I am happy and it serves the purpose. Alright? So, yeah. Thank you. Please share it with your friends. Let me know any difficulty if you have. कोई difficulty है आपको इसमें? Do you have any difficulty? Any doubts? Or any doubts or difficulties? Please let me know. Okay, thank you. What about others? Anybody? No. All right. No problem. Enjoy. Take care, and we will soon see in the next session. Okay. Thank you. Thank you. We will end the thing now. Thank you for joining in.